They truly are miracle workers when it comes to putting things together. They've done an absolutely fabulous job working with all of the staff, the foundation, and all of the volunteers. And I've been a fan of Ross Camp Institute from the first day that I met Bob and Diane. And they talked to me and my husband Max about, it was at Jane's house actually, about Ross Camp Institute and how much they are philanthropists in the true sense of the word for all the right reasons, for all the causes they support, but especially for this cause because it is personal. Bob talked about the stories that affected his family and why he's so passionate about this as his mission. And if you've ever talked to Bob about it, it becomes your mission too. And I would say that I was surprised by how quickly this luncheon sold out, but I'm not at all, because I think when Ross Camp Institute puts their name on something, I think all of us in the community know it's worthy of our time and our financial donations as well. You're going to learn a lot more about Ross Camp Institute, but I actually had a chance to tour the Institute and to interview Dr. Crawford and some of the other doctors and researchers at the Institute. Each had their own unique perspective on their part in that mission. And it is amazing the work that they're doing. It's being done at some of the largest labs and research hospitals across the world, but it's being done right here also in Sarasota. It's hard to believe that this is right here in our backyard. And you'll learn more about why the funding for Ross Camp Institute is so unique and why it gives the scientists the autonomy to follow the pathways that they want to follow. You're going to learn a little bit more about that in a video coming up. But I think also why so many of us have supported this cause, because Alzheimer's is something that affects the Suncoast community so greatly with the number of seniors that we have in our community. And we all know that Alzheimer's is a disease that does not just affect the person who has it, it greatly affects their family, the caregivers, friends. It's something that affects their whole world. And something really struck me as I was just happened to see a commercial on TV, one of those ones you're walking through the living room and you stop because it was that moving. It was an Alzheimer's Association commercial, and it said, the first person to survive Alzheimer's disease is out there. And I thought, there are no survivors of Alzheimer's disease. At this point, we don't have the treatment or a cure, and if you get that diagnosis, you do not have a chance of survival. And that's really hard to accept as the patient and the family. So that's why we're here, because we want to forge ahead toward a cure, or to a wonderful treatment, or to multiple treatments. So I think that it's going to be a fun luncheon. You're going to learn a lot. This is different. We all go to a lot of luncheons in Sarasota, but this is unique because you're going to learn a lot. You're going to leave here with a lot more information than when you walked in the door. And you'll have a chance to ask questions. So do not fear. You can write them down. You don't have to raise your hand like in elementary school. You can just write them down, send them up here, and if no question is too strange, we will work to get them answered. So I hope you enjoy being here today, and we thank you so much for your support. And I want to ask Roxy to come up.
Thank you, Haley. And may I do a tribute to ABC7 and Irma coverage and what you all did to keep us safe and knowledgeable. I have talked to so many, and I think we're in a neurological post-Irma state, and it's makes you appreciate what's important in life and who you care about. And, meeting even strangers and having a greater interest. Brian Lipton and I were talking about that, and Chip and I as well. So I'm glad that obviously we all survived as well as we did. But again, Haley, thank you for the great coverage and the service to our community that ABC7 did throughout all of that. I am just delighted to see this room filled of folks that want to learn more, may know a lot, but want to learn even more, or don't know a lot about the Ross Camp Institute. They're world renowned, and and to have them in our backyard, and for us to brag about their being here, along with our beaches and our arts and so many things that are real treasures in our community. This clearly is a cornerstone and one of those. Before I continue, I want to acknowledge my terrific colleagues that are here today. Laura Spencer, Patricia Martin, Abby Oaks, Murray Devine, and our sister foundation, the Manatee Community Foundation, Susie Atherton. We also have a special friend here in Chip Gaylord. He's a former chair. He, because we have an in-house corporate counsel, he loves it when I refer to him as our outhouse counsel. But his law firm is our outhouse counsel as well, and through the Kaplan Fund at the Community Foundation. He's also a generous sponsor of this, so thank you, Chip, for that as well. I went to the Ross Camp and spent some time with Mike and Fiona when I first came here 6.5 years ago. I really wanted to get out in our community and understand our nonprofits that were here and the work that was happening. For me, I have a story that I'm sure many of you can also tell. My mother had Alzheimer's dementia. I didn't quite know what to call it, but she was on a 12-year journey with her experience with Alzheimer's and ours as a family. I was her caregiver, primary support person for the first 11 years of that, and when we lived here, she moved to where my sister was. But we spent time in assisted living and the healthcare and then memory care for the last 6 years of her life. We were the lucky ones in that my mother knew who we were, and she never, ever, even though she had macular degeneration, when she heard our voices, she would immediately know who was there. So while her short-term memory was not very good, we had those long-term memories that she could still cherish and talk about and really respond to. But my own personal experience as we have music too, as a caregiver, as someone who was my mom, just this work is so personal to me, as I know it is to so many in this room as well. So I really applaud, and I thank the Ross Camps for their vision to create this and know how critical this is as well. For us, being a sponsor was really easy. We have a lot of donors at the Community Foundation that support organizations dealing with Alzheimer's in particular, and a lot of it has to do with their desire to support caregivers and current things. So as I look at what Ross Camp is doing on prevention, cures, treatment, absolutely critical, obviously, as we're an aging population as well. Another reason we saw some links here, the neurological brain development. Many of you know we lead the campaign for grade level reading in Sarasota County. It's getting all children to be reading at the 3rd grade level by the end of the 3rd grade. It's a real marker, halfway to success in life, our ability to read. But we spend a lot of time on birth through 5 and all the neurological things that are happening in your brain as it's developing. So as I look at that early spectrum of life and brain development, and you think through the end of life in our brains and what's happening, there's some, to me, great linkages there as well. I'm so proud, as many of you, this community rises to the occasion with philanthropy, to be a catalyst, to solve problems, to make a difference, and have assistance for so many people. We truly believe that each of us in this community and each of us in this room has the potential to impact another person, a cause, our community. So I really salute all of you who took the time to be here today. You're going to leave here equipped to be an advocate for what Ross Camp is doing, and all those, any type of support can truly make a difference. So we're privileged to have Ross Camp in our community, and I am so looking forward to what I'm going to learn here, and I'm going to be smarter and a better advocate as well. So thank you for the privilege of being able to be a sponsor here, and I just think this, for being sold out like really, really fast, that says something about our community. Thank you.
to introduce Dr. Michael Mullen. He's an internationally recognized authority on Alzheimer's disease and related neurodegenerative disorders. He co-discovered the first ever genetic causes of Alzheimer's disease in the early 1990s. Dr. Mullen trained as a physician and scientist in the UK, receiving both his medical degree and PhD in molecular genetics from London University. Practicing as a physician, he specialized in the diagnosis and treatment of Alzheimer's disease. He spent his career understanding the causes and cures of dementias and has co-authored more than 250 papers on Alzheimer's disease and related disorders. He's a co-founder of the Roskamp Institute and currently serves as the Institute's executive director. He also serves as CEO of Archer Pharmaceuticals, a spin-off of the Roskamp Institute, which has advanced a novel treatment for Alzheimer's through human clinical trials. Welcome, Dr. Mullen.
Thank you, everybody. It's a real pleasure to be here again. I am overwhelmed by your support of the Institute and in particular its mission to, as you know, find new treatments and cures for Alzheimer's disease. So my mission this morning is to tell you a little bit more about what Alzheimer's is, why it presents the way it does as a memory dementia and not some other type of dementia, how the pathology that we've learned about for so long is lending itself to new therapies, what we can tackle, what we can target from the pathology that we've been studying for so long. And importantly, I think, my message is going to be about what we can do now as we wait for drugs to progress through clinical trials, which is a long and arduous process, as you know. What we can do now to reduce our risk. Every one of us can do several things today to reduce our risk for Alzheimer's disease, and I think that's an important message that needs to be dissipated through our community and other communities. So let me show you the frightening picture first, which is the prevalence of Alzheimer's disease. So if you think of all the people that you know over the age of 65, as we stand here today, 1 in 8 of those has Alzheimer's disease. By the time we get to 2050, 1 in 5 of individuals over the age of 65 will have Alzheimer's disease in this country. If you add up those numbers around the world, we're talking about 150 million people, that type of number. So, what is Alzheimer's disease and why is it characterized by memory loss? As I mentioned, if you have a disease like a frontotemporal dementia, memory loss is not the primary presenting complaint. It's usually behavioral disturbances and mood disorders. But Alzheimer's, as we know, is always identified with memory problems. Why is that? So we're looking to explain that now. So I want you to get to know these characters. The hippocampus, or if in the plural it's hippocampi. Hippocampus means seahorse. And if you type in hippocampus and seahorse on Google, this is one of the first pictures that comes up. So this turns out to be the first piece of fake news that I'm going to share with you today about Alzheimer's, because that isn't the reason that they are called the hippocampus. They do look like seahorses, but they look like it in cross-section. So I don't know if you can see the curve, the abdomen of the seahorse there, but the ancient anatomists saw that, and that's why they named it the way it did. The red areas at the top are areas of neurons that connect with each other in a very intricate pattern. And this is where the seat of memory occurs. This is where new memories are formed. So that as I talk to you now, the information that I'm giving you is being relayed through this part of your brain. It's on both sides of the head, in the temporal lobes, just behind the ears, just inward of the ears. And all memories are formed there. And so, because Alzheimer's disease tackles the hippocampus first, and destroys the hippocampus first, we stop forming new memories. So although we talk about Alzheimer's disease as a loss of memory, it's more accurately a disease of not forming memories in the first place, and I'll get to that in a bit. So we have about 86 billion of these things, neurons, in our brains. We start off with about 100 billion, and we lose the ones we don't need through childhood and adolescence. But the important thing to understand about them is they form these electrical circuits, very intricate electrical circuits, beyond our understanding currently. We can't mimic them with computers, but we're trying to. Heaven knows what we produce when we do. But any single neuron can connect with about 10,000 others. So these are highly complex units. Importantly, when one neuron connects to another, it does so through these kind of foot processes, which are known as synapses. So the way it works is one neuron has an electrical impulse moving down its branches, and then it contacts another neuron. At that gap, there's actually a chemical jump across the gap, and that jump is made by what we call neurotransmitters, like acetylcholine, which are targets of the drugs that we have currently available for Alzheimer's disease, Aricept and Exelon. When the chemical gets to the other side, it creates an electrical impulse, and that's how the information is transferred from one neuron to another. So these junctions, called synapses, are exquisitely important in our long-term preservation of memory. The more synapses we have, the more connections we have between neurons, the more we can protect against insults like Alzheimer's disease. How do you get more connections between neurons? Well, one way to do that is to use your minds a lot, and I'll get into that in more detail. So I've highlighted there one of the synapses. So here we are again with the hippocampus, and as I speak to you now, the information is being integrated in the hippocampi on both sides. So auditory information, visual information, your eating, so gustatory information, olfactory information, is all being synthesized and brought to the hippocampus. And very interestingly, from there, the hippocampus integrates it into a package that it can readily access again, so that when you're presented with the same stimuli in future, you can go back and say, yeah, okay, I already know that, or you can go back and say, this is new, I don't know it. The information isn't stored in the hippocampus in the long term. In the long term, it's stored in the rest of the cortex. So this is the reason why long-term memories are preserved in Alzheimer's disease, because the rest of the cortex does get attacked by the disease, but not early. Early on, it's only the hippocampus. So we can't form new memories, but we can access old ones. So it's very common to hear that people with Alzheimer's disease are recalling things from 20, 40, 50 years ago, and in the end, that's all they can recall, because all newer information is lost. And importantly, the first symptoms and signs of Alzheimer's disease tends to be inability to acquire and learn new information, and that's because of the destruction of the hippocampus. So, why is that happening? Why is the hippocampus being destroyed? And this is a story of good proteins turned bad. So the first one that you may have heard about is amyloid, and Dr. Crawford and I were in the team that found the first ever genetic causes of amyloid, and showed that mutations in the amyloid gene give rise to increased levels of amyloid and consequently early onset Alzheimer's. And that's really been one of the prevailing hypotheses about how to tackle Alzheimer's disease since the early 1990s, that if we can reduce the level of amyloid, we can stop the disease, and I'll get into that in more detail. But basically, amyloid comes from a much longer protein, and you can see it here. It's cleaved from that longer protein, which is called the precursor protein, by two enzymes which act like scissors, and they cut it out. We don't really know what the function of amyloid is, although it's probably associated with information and actually responding to information. But the important thing to note here is that you were all making amyloid from about 9 months before you were born. So almost at conception, we start making this. And it's not a problem for us for most of our lives. It is only really made in the brain by neurons, and through various mechanisms, it's cleared from the brain as we age, normally. But in the case of predisposition to Alzheimer's disease, and aging in general pushes us in this direction, it starts to accumulate in the brain. And that's probably because it's not cleared into the blood, and it's probably because it's not broken down in the brain. So as a consequence of that, it starts to build up. The other villain of the piece is tau. Tau is also a fantastic protein, and without tau, we'd have all sorts of problems. What does tau do? Well, tau, my best analogy for tau is that if you think about railway tracks, the metal railway tracks, there's usually wooden, we call them sleepers in the UK, and they're still called sleepers here. But anyway, it's the wooden piece that go under the railway tracks, and the tracks are nailed to it. So it keeps the tracks together, and there are tracks inside neurons. And those tracks are responsible for the transport of chemicals from the cell body to the very tips of the branches of the neurons to touch other neurons, and vice versa, and back again. And so tau holds those railway tracks, called microtubules, holds them together. When tau goes through chemical changes, it prefers to bind to itself than it does to the railway track, and forms these clumps, which we call neurofibrillary tangles, and you can see them on the right-hand side here, inside the neuron. So these black tangles represent the fact that that neuron is now no longer working, it will be non-functional, and this correlates very well with what we see clinically. So the more of these tangled neurons we see, the more we see destruction of our memory function and other functions as they progress. So, very recently, in the last 5 to 10 years, we've gained access to visualizing these things in life. What I'm going to show you, these techniques are not used for clinical diagnosis, they're used for research purposes. But what you can see on the top of in the left-hand corner, in normal adults, it's very important to understand that the two columns on the left and the center column, those are in normal adults. And what you can see, that where it's lit up in green on the top left, that is tau beginning to accumulate in a perfectly healthy brain. Underneath it, you can see amyloid beginning to accumulate. Both of these things can occur 10 or sometimes 20 years before we see the first symptoms. And then if you look at the individuals in the middle, they're also normal, but they have very high levels of tau and amyloid. They may be driving around, flying airplanes, operating on us, all sorts of things. Cognitively, they're normal. But then as you see, we move to the right-hand side, the levels become very high, particularly of tau in the hippocampus, and that's when all the clinical signs and symptoms onset. So knowing that sequence is really important for us, because if we intervene on some of those targets too late, we won't have any effect, and I'll give you some details of that in a minute. Conversely, we don't really want to attack targets that are way downstream, where the disease has been running for a long, long time, if we can stop the whole process by hitting amyloid and tau early. So what I'm doing in this set of slides is relating the pathology to the clinical signs and symptoms. So here's the amyloid buildup in plaques, and as I mentioned, that occurs in cognitively normal people. Once we start to see these, the tangles in the tau, now individuals are starting to show clinical signs and symptoms. And as that progresses, we lose neurons. So if you compare the size of the brain in the advanced Alzheimer's on the right, you can see that there's much less of it, and there's less of it because the neurons have died and have been cleared away. So we start to see these big holes on scanning. And in particular, the hole, I can't indicate it here, but the hole on the right at the bottom is where the hippocampus used to be. And then, of course, as the disease progresses and the brain structures are deteriorate more, then we go into full-blown dementia. So that piece in the middle, mild cognitive impairment, is just where we have one clinical symptom. It's usually memory, but it doesn't impact the rest of our lives. It doesn't impact our daily functioning. But memory on its own is an issue, but that progresses in most cases to Alzheimer's. So this is a complicated slide, but again, it's important from the point of view of understanding when we can predict Alzheimer's disease. We often get asked this question, can you look in advance and tell me, am I going to get the disease? So if you look at so what we have here is time along the bottom, so we're actually running over about 30 years on this slide, from the left-hand side to the right. And up, in the vertical axis, we have the degree of aberration of any one of these tests. So the first test that starts to go positive is cerebral spinal fluid levels of amyloid. And what we see is a reduction in the level of amyloid in cerebral spinal fluid, particularly the longer, stickier form. You might ask, why would you see a reduction? The answer is it's getting stuck in the brain. It's accumulating in the brain, so that's why the levels go down in the CSF. And this is a very, very early sign, can occur as long as a decade before anybody has any clinical signs at all. Following that, shortly after that, there's enough of the amyloid in the brain accumulating for us to be able to use those PET scanners and see it in the brain. After that, we start to see tau appearing in the cerebral spinal fluid. And then after that, we start to see those structural changes. But I want to bring your attention to the green area, because the green area on the left-hand side, you can see, even though you have all of those things going wrong, you can still be cognitively normal. The sections in the middle between the two vertical blue lines, that's when the mild cognitive impairment occurs. And then after that, we move into the dementia range. And you can see there's this width to that green area. High-risk individuals and low-risk individuals. And that's where the next part of what I'm going to talk about comes in. How do we adjust our risk from going from the high risk, where we get it early, to the low risk? So it turns out there's 4 things we really need to focus on. We have to control common medical conditions and diseases. I'll get to a list of those in a second. We need to exercise our bodies, and we need to exercise our minds. And we need to pay very close attention to our diets. The good news, from my point of view, when I look at this, these are all things I can do. I can do them today. We can all do them today. And I'm going to show you the impact this has on reducing our risk. So here's a list of risk factors, medical risk factors for Alzheimer's disease. These increase your risk, and if you look at the numbers in red, that's the number by which it increases your risk. So if you look at late life undiagnosed diabetes, it increases your risk by about 3 1/3 times. That's an incredible increase in risk. If I said, okay, if I do this today, my risk of having a car accident increases by 3 1/3 times, I think that would get my attention. So the good news is, it's easy to diagnose diabetes, and it's easy to treat diabetes. So everything on this screen is preventable. All those red numbers can be reduced to 1. In other words, no increased risk. And you can, and Mike Murray, I think, is going to pick up on a number of these, because some of these are dietary. So high levels of homocysteine, for instance, can be corrected by B12, B6, and folate supplementation. Vitamin D deficiency can be easily corrected. Smoking, cholesterol levels, and so on. And Dr. Crawford will talk extensively about the risk for Alzheimer's disease and other dementias conferred by increased traumatic brain injury. And that's the only thing on the list that we can't really do much about, except, and she'll get to this, which sports we play. So the hippocampus, as I've mentioned, tends to shrink with age anyway, and it particularly shrinks if you have the risk genes for Alzheimer's disease. So if you have a variant of the gene of ApoE, apolipoprotein E, which we'll talk more about, that can drive you into early shrinkage of the hippocampi. And what I love about this is 18 months of physical exercise of people that were at high risk for losing their hippocampi by virtue of the fact that they had the genetic predisposition. And so the ones on the right who had very low physical activity, the long bar, they lost about 3% of their hippocampal volume in 18 months. That's a lot. The individuals on the left had high physical activity incorporated into their lifestyle, and they basically neutralized that loss. This is a very important slide. It means that we can go against the genetic predisposition and neutralize it. So genes in Alzheimer's disease shouldn't be regarded as fatalistic. There are things you can do to oppose their effects. There are many examples of that, by the way. This is one of my favorite examples. So this is the story of the London taxi drivers. So London taxi drivers to this day, even though we have GPS, still have to learn what's called the knowledge. The knowledge basically is a mental map of the whole of London. And it's not just learning the road names, it's how you would move from one to the other. So the bars on the bottom right-hand side are capture the size of the hippocampus at time t equals 0, when they go into the cab office and say, I want to learn to be a taxi driver. And then several years later, when they have learned to become a taxi driver. And what you see is the qualified trainees, where the asterisk is, their hippocampi have increased in size by, it looks about 33%. Whereas the non-qualified trainees, the individuals that started the program but didn't get through, or ordinary controls, which include people like bus drivers that drive through London every day but don't have to learn anything other than the single route they're on, their brains don't grow in size. So that using your brain increases its actual size. Why does it do that? Well, in general, it's not because we're making more neurons, it's because we're making more synapses, more connections between neurons, and that's why it physically gets bigger. There are examples of this, not just with the hippocampus, but with the whole brain, not just linked to the use of the brain, but to exercise as well. And putting the idea of diet and activity together, which is probably one of the best ways of all that we can combat our risk. We see studies like this, which would also capture our attention if I was presenting from a pharmaceutical company, for instance. If I was showing you data that we could reduce our risk for Alzheimer's disease by 50% by taking a drug, we would all know the name of that drug, because it would be on TV about every 30 minutes. It would be a fantastic breakthrough. But these data here indicate that if you adhere to a Mediterranean-type diet, you have a high adherence rate, and you take a certain amount of physical activity, you can cut your risk to Alzheimer's disease by 50%. This is not a single study, there are multiple studies that show these effects. And one of the most remarkable pieces of data too, which is my last slide at the moment, is about mild cognitive impairment, and the fact that even once that is established, just changing your diet can reduce your conversion rate to Alzheimer's disease by 50%. So we're into the disease. If you do the PET scans and you do you look for amyloid and you look for tau, you're going to see it in these individuals. But the conversion to full-blown Alzheimer's can be cut in half by adhering to a Mediterranean diet. So I'm going to stop there, and I think Mike's going to take over, but thank you for your attention for this part of the talk.
Wonderful information, and even more to come from Michael Murray, a widely regarded leading authority on natural medicine. Dr. Murray is a graduate faculty member and serves on the Board of Regents of Master University. He's a co-author of A Textbook of Natural Medicine, the definitive textbook on neuropathic medicine for physicians, as well as the best-selling consumer guide, the Encyclopedia of Natural Medicine. He's also written more than 30 other books, with more than 6 million copies in print, including his latest book, The Magic of Food. For more than 35 years, Dr. Murray has been compiling a massive database of original scientific studies from the medical literature that support the role of diet and other natural approaches to health and healing. According to Dr. Murray, one of the greatest myths about natural approaches is that they are not scientific. He says the truth is that for most common illnesses, there is tremendous support in the medical literature for natural medicine. Dr. Murray is also Chief Science Officer for Enzymatica, a leading supplier of dietary supplements for digestive health. Dr. Murray.
Thank you. Good afternoon. It's a pleasure to be here. I really appreciate the opportunity to share with you. If you pay attention to the news, it seems like there's always conflicting evidence on diet and lifestyle as it relates to various health conditions. And I think a lot of times it's like the parable of the blind men and the elephant. According to which part of the elephant the physician or the blind person is holding onto, that will become what they think is most important. So what I've tried to do in my career is kind of step back and try to see things from a distance and then get in and look at the nitty-gritty. My mission is to educate and inspire people on learning about and utilizing the tremendous healing power of nature. We're going to talk a lot about diet and as it relates to health, but I think if we really look at what's important in creating health and wellness, there's some key fundamentals that we have to pay attention to. And I always get asked the question, what's the most important thing to do? And my response is that they're all important. Everything is important. All you can do is all you can do, so why not do all that you can do? And instead, many times people wait until something happens to their health before they start being responsive and choosing healthier choices. We've all heard the statement, an ounce of prevention is worth a pound of cure. When it comes to Alzheimer's disease, an ounce of prevention is worth a ton of cure. And there's so much that we can do, both to prevent Alzheimer's disease, and on the flip side, there's so many things that people do unknowingly that really create this condition. When I started my medical training, as Michael and Fiona did as well, Alzheimer's disease was not a very common issue. And some of the statistics Mike was giving were on people over the age of 65. But if we look at the age of 80 or 85, back in the early 80s, Alzheimer's disease probably affected 1 or 2 people over the age of 80. Now it's estimated by the time most people get to be 85, about 50% of them will live longer, but they'll not have their mind. They'll develop Alzheimer's disease. So this is a topic that is important to all of us. So I'm going to just give you, in the time I have, some key considerations. And some of them are fairly well known. The meal that we just had, that was fantastic. I don't know who was responsible for creating that menu, but let's give them a round of applause. Did that yeah, the team did a fantastic job. That was the best lunch at a luncheon I think I've ever had. How many people heard this quote? Let your food be your medicine, and your medicine be your food. That came from Hippocrates, the father of Western medicine. That is the future of medicine. That's the future. We're just starting to understand the impact that food has on our health. How many people have heard this? You are what you eat. Yeah. So don't be fast, easy, cheap, or fake. I just finished a book. It'll be released out in the public in 2 weeks. It's called The Magic of Food. And my idea on creating that title came from just looking at technology. This is an incredible creation. I think we've been awed so much by advances in technology that we've lost sight of something. So I asked the question, which is the greater technology, Apple or an apple? I think it's the apple. I think the greatest technology in the universe is nothing that man has created. It's nature. And the way in which we commune with nature on a daily basis is through the food that we eat. Now, I got the idea to title my book The Magic of Food because I love this quote from Sir Arthur Clarke. He wrote 2001: A Space Odyssey. And he said, any sufficiently advanced technology is indistinguishable from magic. And I just told you that the greatest technology in the universe is nature. We're just scratching the surface in our understanding of the way that food and nature affects our health. Now, I'm very proud. When you write a book, it becomes like your child. And I want everybody to love this book, so I'm making sure that everybody on their way out today is going to get a copy. I think a lot of times people succumb to the thought that there really isn't anything they can do, that they're born with this genetic predisposition to the disease, and they think that that's their fate. The Human Genome Project was one of the largest and most well-designed scientific endeavors ever, and it was going to solve all the problems of health and disease by determining the sequence of our genes. But they had an interesting discovery when they completed this project. They realized that our genetic code is a lot like a computer's hardware. You can have the greatest computer in the world, but if it doesn't have the right software, it's basically worthless. And so what they learned was that there were factors that they referred to as epigenetic. They're around the genes that influence the expression of the genes. And they determined that these epigenetic factors are more important, for the most part. True genetic defects probably account for only 5% of all cancers, for example. And the risk for having a genetic defect for Alzheimer's disease, the true genetic defect is probably around that same percentage. But through things that influence our epigenetics, we can express a risk or reduce that risk. So what are the factors that influence our genes? Our diet, our lifestyle, our thoughts, our emotions, our experiences, and the environment. These are largely things that we can control. And that's certainly true in the case of Alzheimer's disease. Nature is wonderful. Nature is incredulous. It's awe-inspiring. To really appreciate the role that food has in our life and the way it influences our genetic expression, let's take a look at the queen bee. If you were going to be a bee, you'd want to be the queen bee. They're larger. They live greater than 2 years. A worker bee, they're lucky to live a month. You want to be the queen bee. Both the worker bee and the queen bee start out the same. They're identical. Their DNA is identical. Their genes are identical. But the queen bee is fed a different diet in that larva stage. And it activates certain genes that allows her to become the queen bee. The worker bee, they're just fed worker jelly and they become preordained to have that short and hard life. What about these mice? Do they look alike? No. Are they genetically identical? Yes. They did some research on mice, gouty mice, and what they found is that how a mouse was fed when they were pregnant would determine whether they would have a fat yellow offspring or a healthy brown furred active mouse as an offspring. And this was really quite interesting, and it led to looking at human equivalents. So they looked at twins, identical twins. DNA is identical. When those twins are born, they express their genes almost identically. By the time they're 50, they only share 3% of their expression of their genes. So they're two different people. They're two different people. So we can influence our genetic expression through our diet, for both good or bad. And right now, with what the typical American is eating, they're fueling this diabetes, obesity, and Alzheimer's epidemic. I touch on that in the first chapter of the book. I really believe that we're overfed and undernourished, and the foods that most Americans are consuming, these are catalysts for accelerating inflammation, degeneration, and conditions like Alzheimer's disease. If we look at the rate of obesity and diabetes that's happened over the last 20 years, it is staggering. This is an epidemic of our time. And the thought is that as we gain weight, particularly around the abdomen, that leads to insulin resistance, and that leads to type 2 diabetes. The rate of diabetes has increased dramatically. Now, Alzheimer's disease is often referred to by researchers as type 3 diabetes. That's because Alzheimer's disease and diabetes, type 2 diabetes, share so many common features. So one of the things that I really pride myself on is uncovering some interesting literature that really is provocative. And there's research that shows that this epidemic of diabetes, obesity, and perhaps Alzheimer's disease is related to what are called persistent organic pollutants, basically pesticides, flame retardants, plastics, these compounds that are hard for our bodies to get rid of. So here's a review article that was done, and I want to touch on this study that was done. I have to do my weatherman imitation here, because this slide is really important for you to understand. This slide is based on a study of 2,000 people where they took blood samples and analyzed their blood for pesticides. And what they found was that there was no adverse effect of any single pesticide, but when they lumped them together, they lumped 6 together, and they broke people down into groups of 5, where you had the highest exposure down to the lowest exposure. They started seeing some really interesting correlations. Basically, they were looking at the rate of the development of diabetes based upon body mass index and how much of these pesticides they had in the body. So what they found was that the people that had a very low level of these pesticides, they didn't get diabetes no matter how obese they were. On the flip side, even people that were thin, if they had higher levels of those pesticides, they had a dramatic increase in the risk of diabetes. Yeah. About 20%. So this raises the question. No one's really looked sufficiently enough at the role of pesticides in Alzheimer's disease, but if diabetes is so linked to these compounds, what is the effect of these pesticides in Alzheimer's? When I first met Michael and Fiona at the Roskamp Institute, I was just thrilled because their areas of expertise at the Roskamp Institute is really well positioned to have a greater look and greater evaluation of the role of all these different factors that affect Alzheimer's disease. So they are able to step back and see all the different parts of the elephant. They did their work on the Gulf War syndrome, and they had some very interesting findings from that research. And I think it'll be interesting to apply some of those findings to Alzheimer's disease. Okay, so let's talk about prevention. If you go to the doctor and they do a test and they say, oh, you've got prediabetes, they don't really talk much about diet and lifestyle. What they want to do is they want to put you on a drug. They put you on a drug called usually metformin. That's the first step. Okay, and the reason they do that is because the drug detail person tells them about a study called the Diabetes Prevention Program. This was a study where they took people who had diabetes or had prediabetes and they gave them either a placebo, metformin, or they had them walk 30 minutes a day, 5 days a week. Okay, the group that got the metformin, yeah, they had a 31% reduced risk of developing diabetes, but the group that walked 30 minutes a day, 5 days a week, reduced their risk of having diabetes by 58%. Yeah, so what is more effective? Now, here's what I did. I looked at this study more closely, and I looked at it by age, the subjects by age. So, what they found was that people under the age of 45, they responded pretty well to the metformin. There wasn't that much difference between metformin and exercise. But look at the people over the age of 60. They don't respond well to metformin. They respond better to lifestyle. They respond better to diet. We know that. But yet, that's not being instituted. They're being led down a false path. Okay, so that's just me. So let's talk a little about some key dietary strategies, not just to reduce the risk of Alzheimer's disease, but really just to reduce the risk of all disease and feel better. I think a lot of times people don't want to give up their comfort food because they think they'll be missing out on something. But you know what? Nothing tastes as good as healthy feels. And you've got to start eating for health. So you have to eat to improve insulin sensitivity, eat a low carbohydrate, low diet, eat a rainbow assortment of fruits and vegetables, reduce exposure to pesticides, eat to enhance detoxification, reduce the intake of meat and other animal foods. By the way, when they looked at those people that had the higher levels of pesticides in their blood and the risk to diabetes, 90% of those pesticides came from meat and dairy. We always think about pesticides and we immediately think of produce, but one of the real problems in our food supply is the higher you go up on the food supply, the more polluted it is. So you have to eat the right types of fat, keep salt intake low, and drink plenty of water. Michael mentioned the Mediterranean diet. You had a perfect example of the Mediterranean diet for lunch. Now, this is the typical Mediterranean diet pyramid. I've made an improvement. Let me just show it to you. Here's the improvement. Let me take you back. That's the traditional Mediterranean diet. This is what Dr. Murray does to it. Okay? I don't think we need to be loading up on grains anymore. Years ago, when we were very physically active, we needed a lot of calories. But now, there's better choices of where to get your calories from. In particular, we have to utilize the benefits of fats, the healthy fats. Not the wrong types of fats, but the good types of fats. The Mediterranean diet works fantastic to lower the risk of cardiovascular disease. Michael mentioned its role in reducing Alzheimer's disease. But they found they could significantly enhance the benefits of the Mediterranean diet if it included more nuts. Consuming 3 servings of nuts per week reduced overall mortality by 63%. That's significant. They found that having 3 servings of walnuts per week reduced the risk of dying from cancer by 50%. Yeah, fantastic. So it's nuts to avoid nuts. Yeah. These are the good high-fat foods. Stay away from common vegetable oils, soy, safflower, sunflower, corn. These oils really promote inflammation, and that is not good for your brain. Your brain is literally a vat of fat. So when someone calls you a fathead, you should just be thrilled and proud because you know you're eating the right types of fat. The types of fat that you consume in your diet determine the types of fat that you have in your brain. The type of fats that you have in your brain determine how well your brain functions. It also determines your risk for Alzheimer's disease. So get more of these good high-fat foods. The monounsaturated fats that we get from nuts, seeds, olive oil, avocados, very important, as are the long-chain omega-3 fatty acids that we get from fish and fish oil supplements. I'm going to wrap up here real quick. One of the principles of my book is that it's important to eat a diet that is diverse in plant foods, that are diverse in plant pigments in particular. There are different types of plant pigments. The ones that I love are flavonoids. I love flavonoids. They're just fantastic. What are flavonoids? Well, they're the compounds that are responsible for the pigments of many fruit, flowers, and vegetables. As a class of compounds, there are over 9,000 flavonoids that have been identified. They're the compounds that provide the medicinal effects of blueberries, ginkgo, St. John's wort, all these medicinal herbs. These flavonoids, they've been referred to as a class of compounds as biological response modifiers. That's a mouthful. What does it mean? Well, they modify our response to the environment. These are tremendously pharmacologically active compounds. They're very active. The way in which they're utilized by the body is really interesting. Now, in America, we love things that are foreign. So we like things that are super. And so if we look at what's popular in health food stores now, we get a lot of super fruits, like noni, and goji, and sea buckthorn. Well, I think the common, familiar fruits are also super fruits. And just for an example, can an apple a day keep the doctor away? Well, it can keep Alzheimer's away. Apples may be the most protective fruit against Alzheimer's disease. In one study, they evaluated the intake of different foods, and they found that eating apples 3 times a week was associated with a 34% reduced risk of developing Alzheimer's disease. Well, I think there's more you can do, because there's synergy among these different components. I'm primarily a medical researcher, and I get amused by some of the titles that you'll see in journal articles. I love this one. Apples and cardiovascular health. Is the gut microbiota a core consideration? I love that. And I love these authors, especially the last one, Julie Lovegrove. What a great name for doing research on apples. How many of you have heard of the microbiome? This is the microbiome refers to the collection of microorganisms in our intestinal tract. And the type of organisms in our GI tract determine our risk for many different health conditions. Collectively, there are about 10 times as many bugs in your intestinal tract as there are cells in your body. So it's a huge number. And we can influence that microbiome through the diet. And one of the beneficial effects of the Mediterranean diet and many of the foods that are associated with reducing the risk of developing Alzheimer's disease relate to their influence on the microbiome. And this is a real key area of focus of the Roskamp Institute moving forward, because it's such a key aspect of our health and apparently our brain health. And you all heard that berries are superfood. Well, why are they super? They're super because of these colorful compounds known as flavonoids. I'm trying to instill love for the flavonoids within all of you. Yeah, these compounds are very important to include in your diet. Now, there are other sources of flavonoids. And by the way, you all know what an antioxidant is. It's a compound that protects against oxidative damage and helps us fight aging and many of these chronic degenerative diseases. And when I'm talking to physicians, I ask them, which is higher in antioxidant capacity? A cup of red kidney beans or a cup of blueberries. And most of them have heard that blueberries are really powerful antioxidants, but the red kidney beans have higher antioxidant activity. So even other forms of vegetables are very high in flavonoids, plant pigments. One of the ways in which flavonoids work in our body is by enhancing the function cellular compartments known as mitochondria. Mitochondria are responsible for producing energy in the body, in our cells. Decreased mitochondrial function is one of the key hallmarks that leads to excessive damage to our cells, leads to early aging, and leads to chronic degenerative diseases, particularly neurodegenerative diseases like Alzheimer's disease and Parkinson's disease. So we want to protect against mitochondrial damage. Now, this is going to be a little bit technical. I'm going to try and break it down because it really attests to the magic of food. I've tried to express my love and appreciation for flavonoids. It goes really deep because these magical compounds work in ways that are so unfamiliar to modern pharmacology, which is the study of drug action. When we ingest a flavonoid, it is quickly bound to another molecule called glucuronic acid. And that molecule inactivates that flavonoid. But at areas of need, that glucuronide is split. So what is on the screen is an illustration of a study that was done in 2014 that proved this thought that many of us have, and that is that areas of need, whether it's a cancer or inflammation, or in the case of Alzheimer's disease degeneration, there's a decrease in mitochondrial function, and that causes the cell to release compounds that break that bond and free up that healing flavonoid. And in this study, what they showed was that the flavonoid was able to get into that cell, get into that mitochondria, and repair it and restore its health. So what's the bottom line? You want to flood your body with flavonoids. You want to eat lots of colorful vegetables, lots of colorful fruit, and don't forget chocolate. I want to give you something to remember me by. I'm going to prescribe to everyone to eat 1 to 2 ounces of dark chocolate. The darker, the better. Yeah. Why? Very rich in flavonoids, very good for you. So these are the 7 keys to wellness again, and I just want to end by saying avoid toxins and support your body. I believe that historians, when they look at our era, they're going to look back and they're going to say, what were those people thinking? Because many of the common drugs that we're utilizing promote Alzheimer's disease, promote degeneration. And these are just the top 7 that I found, led by acetaminophen. Acetaminophen's time is past. This is a drug that is used by 50 million people every week. And what this drug does is it acts as a toxin, and our body utilizes a very valuable compound called glutathione to deal with the acetaminophen. And that leads to making our cells very susceptible to damage, particularly our brain cells, and particularly our liver, and highly replicative cells. So these are some of the drugs that I think are really problematic, and again, there's good research that calls them out as possible contributors to this Alzheimer's epidemic. So again, I want to thank Jane and Bob and Diane and everyone associated with the Ross Camp Foundation, and Michael and Fiona for helping me be here from the Ross Camp Institute. And I want to thank all of you for your attention. Enjoy the book. God bless. Thank you.
I was hoping that Dr. Murray would mention wine as one of those antioxidants. In moderation. I think we're going to get into that in the panel a little bit, because we hear all these conflicting things. Alcohol's good for you a little bit. No, it's not, so we'll talk about that later. But now I want to introduce Dr. Fiona Crawford. Her research was carried out in London as a member of the team that identified the first genetic causes of Alzheimer's disease, as we talked about earlier. Relocating to Florida in 1992, she discovered the Swedish mutation which causes early onset Alzheimer's and has been used in innumerable laboratory models of Alzheimer's worldwide. She co-founded the Roskamp Institute, which is now home to a staff of more than 60 scientists and clinicians. She currently serves as the Institute's president and CEO. All Institute research programs are focused on clinical translation, and Dr. Crawford has developed laboratory models for traumatic brain injury, post-traumatic stress disorder, and Gulf War illness. She directs all military research programs at the Institute, as well as the novel 4-year PhD program, which to date has graduated 8 new neuroscientists. Her many research programs are funded by the VA, the DoD, and the NIH. She regularly presents her research at national and international meetings and has published more than 160 peer-reviewed research papers. Welcome, Dr. Crawford.
Thank you very much, Haley. And thank you all so much for coming out today to support the Roskamp Institute. Really, really appreciate your support. Now, Dr. Mullen and I get to come to this event and be the face of the Roskamp Institute. But the Roskamp Institute is a team of incredibly dedicated, very talented, multidisciplinary scientists, some of whom are here today. And I would just like to acknowledge our staff while I have the chance up here on the podium. Thank you all. So I'm going to be talking about our traumatic brain injury program. Dr. Mullen mentioned earlier that traumatic brain injury, or TBI, is a key risk factor for Alzheimer's disease. We have known this for a long time. We have been working on traumatic brain injury since the late 90s because of this fact. But over the last maybe 10 years, it's kind of been rediscovered. The focus on traumatic brain injury has arisen really for 2 main reasons. One being the wars in Iraq and Afghanistan, and also our increasing awareness of the devastating long-term consequences of repetitive, often very mild head injuries. I'm going to be talking about those today. So traumatic brain injury is a major cause of death and disability. I believe there's an estimated 5 million people living in the US today with debilitating consequences of TBI. It can cause physical disabilities, neurological deficits, behavioral changes. Certain traumatic brain injuries do result in very dramatic behavioral changes. And as I mentioned, it's got military and civilian relevance. So what actually happens when we sustain a TBI? And Jane is just going to start this video for us. So Mike talked earlier about tau and the fact that tau is a protein that is a structural component of neurons. So here we're going inside the neuron, and this is a healthy neuron at this point of the video. That sphere is a molecule or a vesicle that's being transported from one end of the neuron to another. And in blue we have tau protein, which provides a structural stability to the neurons. But if we sustain an injury, if we have a blow to the head, if there's a shearing force on the neurons, or if there's swelling and breakages, then the tau comes off the neurons, it can build up, result in those tangles that Mike presented earlier, and we end up having neuronal death as a consequence. And when we have the neuronal death, then that leads to the brain atrophy that Mike showed during his presentation. So these can all happen whenever we have a traumatic brain injury. These neurodegenerative consequences, which can lead to TBI, lead to Alzheimer's disease, and can lead to other neurodegenerative diseases. I mentioned the transporting from one end of the neuron to another. This is a nice electron microscopy image of human neurons, and you can see the length of the neuron and then this bulge, this swelling part in the middle. So I like to think of the neuron, because there's lots of things being transported up and down the neuron and communications with all those other billions of neurons. It's like a highway or an interstate. So if you picture the I-75, for example, and think of all the traffic and all the things that have to get transported maybe between Tampa and Naples, going in both directions. And then there's some sort of accident happens somewhere in Sarasota, probably University Parkway. So we have maybe a couple of lanes closed. There's maybe still some traffic getting through, but it's really backed up. So you see here we've got this swelling. So the cargo that was meant to be going down to Naples or back up to Tampa starts to build up, and it's not meant to build up. And maybe then all the lanes get closed and the whole thing gets shut down. And so we stop having the neuronal information being transferred from one end to the other, and from there to all of the accompanying neurons, all the neurons that this one is connected with. One of the big things that's happened in TBI is that we now recognise it doesn't have to be a very severe TBI to have very devastating consequences. We now know that mild TBI is a real problem. Largely, or one of the big problems, is that it goes unrecognised for so long. And we actually cannot detect mild TBI in the same way. So you cannot see the effects of a mild TBI on a regular MRI scan. You don't see those big obvious changes that you get if there's a lot of edema or a significant bleed. So this is just one image of one of the tools that we now can use to detect mild TBI. This is a modified type of MRI. It's called diffusion tensor imaging, and it uses the ability of molecules to be detected when they're being directionally dependent. So in other words, molecules that are being transported up and down the neurons, as I just showed you. So there's a direction to that, and we can track that with this DTI imaging. So if you look at the image on the left of control brain, you can see this gives you the really nice network. There's a really dense network of neurons throughout the brain, lots of connections happening to every part of the brain. But the individual on the right who's been injured, you can see there's lots of gaps. There's thinning of the neuronal connections throughout the brain. And so that means that the messages just aren't there anymore. The connections from one part of the brain to the other just aren't there anymore. So, looking first at the Department of Defense statistics, this is an old graph now, this is from, I think, 2012. But this shows how the traumatic brain injury population in the DoD got divided among the different levels of severity since the start of the century. And you can see in orange, that top line shows a dramatic increase in detection, maybe recognition of mild traumatic brain injury, as compared to the more severe or moderate injuries. And one of the reasons that this really has become recognized as a signature wound of these current conflicts is because in previous wars, Korea, Vietnam, the body armor was not as good as it is today. So folks were actually dying as a consequence of injuries that these days they can actually survive, but the brain remains relatively unprotected for all the obvious reasons. Our troops need to have their senses free to be able to operate, to keep them safe. So we now see more traumatic brain injury than we ever saw in previous conflicts, and it has been called the signature wound of these current wars. A more recent chart here from 2014, this is just in the first half of 2014. Again, the DoD reports that more than 80% of all TBIs were mild TBI. And we're now recognizing that mild TBI leads to later life neurodegeneration through some of the mechanisms that Dr. Mullen mentioned that are related to Alzheimer's disease, and triggering almost certainly of other pathological proteins which are involved with other neurological conditions, such as Parkinson's disease or motor neuron disease. Now, in terms of civilian injury, the issue that has come to the fore is NFL, American football. So this really has become a big deal. Publicly, politically, huge amount of money involved, of course, with the NFL. A lot of recriminations, a lot of lawsuits, and so on and so forth. But you only have to look at a couple of these images, and you can see these folks are getting head injured over and over again. And it's not just American football. We can now look at soccer, heading the ball repetitively. That's a repetitive mild traumatic brain injury. Ice hockey. That's part of the actual game. That's not the fights breaking out, of course. Cycling, another key cause of sports head injury. And of course, the sport that originally enabled us to recognize the long-term consequences for neurodegeneration was boxing. This actually isn't from boxing, this is from mixed martial arts, where we are actually come up with a whole variety of ways now to give ourselves head injury and call it entertainment or sport. The long-term consequences are devastating and really need to be addressed. So at the Roskamp Institute, we are working to model the disease in our laboratories, try and understand the consequences of TBI and how we tackle those negative sequelae, the neurodegenerative pathways and signaling mechanisms that get triggered as a consequence of the injury. Now, we work with mice primarily, and of course there's issues about the mouse brain and the human brain. You can see here, for example, the human brain in front. We've got this folding, these sulci that are formed in the surface of the human brain. We don't have that in mice. There's a much greater cortex in the human brain, most humans anyway, compared with the rodents. And so we do have issues of translation, but at the end of the day, the traumatic brain injury research is about looking at the effects of traumatic brain injury in a brain. It's a mouse brain, but it's still a whole brain. And we as scientists do not yet have the skill or the technology or the resources to be able to model the human brain with cells in a petri dish. So that's why we have to turn to animal models for this research. But the good news is that we can actually model an awful lot of what we see in human TBI in the mice. Here we see the axonal injury, I mentioned it earlier. Those are the long strands of the neuron with those swellings that occur, the axonal injuries. Myelin loss, the protective sheath around the neurons, we see that in our mouse models. And astrocytes and microglia, two cell types that are absolutely hallmarks for neuroinflammation. We can see those in abundance in our animal models as we do in human cases. Now, these are images of tau in human brains. So I guess most people by now have heard of chronic traumatic encephalopathy, which is the term used to describe pretty much all of the NFL TBI cases that you'll have heard about. Chronic traumatic encephalopathy is characterized by tau deposits, and you can see on the left a control individual, and in the middle and on the right, two cases of individuals, one an NFL player, one a boxer, who sustained repetitive traumatic brain injuries throughout their careers. You can see in the top panels the tau in those folds of the brain, maybe because there's actual physical forces, shearing forces there, if the brain moves against itself and against the skull in response to the head injury. And then in the lower panels here we see it in and around the blood vessels and in the cortex. And we can actually model tau in our animal models now, but this has been a problem in TBI research, trying to get tau in our animal models, specifically getting tau pathology that persists after the end of injuries, because of course that's really where we think the danger comes, not any kind of transient changes that then dissipate, but something that persists and lasts for the rest of the life. These are cases, differently staged cases, from Anne McKee's brain bank in Boston. That's the brain bank where pretty much all of the NFL autopsy cases are going to. And what you can see here in these human cases, probably if we focus on the lower panels, that'll be easiest. I can't point it out here, but the brown staining are microglia. Those are those inflammatory cells that I mentioned. And the dark blue or black looking stain, that's for tau. Same tau protein that Dr. Mullen talked about, that we see in the brains of Alzheimer's patients. Here it is building up in these CTE cases. When we look at our mouse models, we can actually see the same thing when we get
Doubles to 2,400 thanks to our match today. So if you look for the envelopes on your tables, you want to make a donation today. The volunteers in the Gray Matters t-shirts will come by and pick up your donation today. If everyone can kind of wave if you're in the t-shirt. Also, the t-shirts are on sale. So please leave and purchase the t-shirt on your way out and spread the word. And hopefully as you wear it, people will ask you, what is Gray Matters? What does that mean? And then you can spread the word and tell them to go to the Roskamp website and learn more. And we'll just keep going with this mission all year. So if you do want to hand in your donations, if you have to raise your hand and someone will come by and pick up your envelope. And then we can get started on the panel. That's the next thing. If you have a question, there are some cards in your program that look like this. If you want to ask a question, You can also just write your question on there, hold up your note card, and we will come by and get it. And then we will answer your question on the panel. So if we're talking and you have a question that comes up, please raise your hand as well. And I'll ask our panelists to come up now. The first question is something that we've been talking about, probably all has been mentioned briefly, but I wanted to kick it off by mentioning Aaron Hernandez. Just a very unfortunate situation all around, of course, but it just came out that he had CTE. And we wonder if any of that may have had an influence on some of the things that happened. We'll never really know for sure. But that's an interesting tidbit to kick off this first question that we are asked, which is for Dr. Crawford. Should I let my kids play football?
So, if I have children, I would not let them play football. That's my opinion. Yes, the Aaron Hernandez story is tragic. If there's anybody who doesn't know, 27-year-old man has played as tight end for the Patriots for several years, and he committed suicide in prison earlier this year, and the autopsy results were released yesterday and showed that he had stage 3 chronic traumatic encephalopathy. So if you remember the images I showed, the pictures of his brain looked like the boxer on the right-hand side, the 73-year-old who had a history of professional boxing. Now, the important thing to bear in mind is that he didn't begin to receive head injuries when he joined the NFL. He had been sustaining head injuries during college football and in the years before. And there's a study that actually just came out this week in one of the Nature journals where NFL players have been interviewed and asked to self-report on their emotional issues and cognitive issues. And it is a complete correlation with the age at which they started with any sport, particularly individuals who began at an age younger than 12, but even if it was after 12 or 14 years old, the emotional disturbances suffered by the NFL players who participated in the study is correlated with how long that they have been sustaining head injuries, basically.
And do you think there is any effect from some of the more recent actions taken by youth football, high school football, college football to reduce contact? Do you think that we will start to see maybe some improvements?
I hope so. I would certainly hope so. It's too early to tell. But I would certainly hope that yes, specifically the measures that are to actually avoid head contact. There have been also developments with helmets and dose meters in helmets to try and understand the nature of the injury, but really the best approach is to try and avoid head injury altogether.
All right, the second question we've received is for Dr. Mullen. How do you diagnose Alzheimer's disease?
So Alzheimer's is diagnosed as a syndrome of cognitive impairment, usually with some visual evidence of changes in the brain, so that can be any number of imaging studies. But the cognitive impairment is best assessed by a neuropsychologist that will be particularly looking for changes in memory early on.
And in combination with the history that we've talked about already, so this early loss of memory and moving to other things. It's important to understand that dementia just means usually loss of memory, some other cognitive function, and that it's in doing something to your social activities or activities of daily life. Doesn't mean anything. It's not really a diagnosis. A diagnosis of dementia just tells you that syndrome is there, but it doesn't tell you what's causing it. So there are hundreds of causes of dementia, but of course Alzheimer's is the commonest.
And then our third question is for Dr. Murray. It is, which is more important for brain health, diet or exercise? Now, I know you said it's all important, but if you had to choose one, I guess we'll pass this down and pass it back.
I always get asked that question. What's the most important thing? I think I clarified that. We didn't even get into the importance of relationships and love in your life. And that plays a big role in brain health. We didn't talk about a lot about lifestyle. And that's kind of, I go back to that blind man and the elephant. I think it's all important, and you can't really separate out what's most important. It's kind of like, I'll use the car example that Bob was using. What's the most important component of your car? It's the one that's not working. So I don't think you can say that. I think it has to be the whole package. Again, all you can do is all you can do, so do all you can do.
So do both. Okay, this is giving us a little feedback too. Our next question about brain injuries. Have you found any significant differences between how men and women recover from similar brain injuries?
To date, we don't have enough information on that in the human population. This is still a relatively young field in terms of having these sort of large epidemiological studies and being able to investigate that. I can tell you that in the lab, we are paying attention to that. We are doing studies on both male and female mice. We do see some differences, not in young mice, interestingly. We see some differences in aged mice. So 12-month-old mice who receive a head injury, we see differences in response between males and females. Interestingly, what we see, and it remains to be determined whether or not this translates to humans, but what we see is that the motor effects, the movement effects, are greater in the female mice, and the cognitive effects are greater in the male mice. But I don't know if that's going to translate to humans yet, but it's absolutely something we need to look at.
This is a great question. 36-year-old husband's mother was diagnosed with early onset Alzheimer's at 48, passed away at 58. Beyond diet and exercise, what else can someone do with a genetic predisposition? If you know you have this gene for early onset Alzheimer's, what else can you do?
So let me just clarify. Very early onset Alzheimer's disease can be caused by extremely rare mutations in that amyloid precursor gene that I showed you, the extract protein, the gene for that. And also there are other mutations that can cause these really, but thank goodness, very rare effects. We really have very little information on what we can do to prevent those with lifestyle, because there just aren't enough of those folks for us to examine. However, but those people are candidates for clinical trials, and there are clinical trials directed specifically at them. For most of us, as I mentioned briefly, there are at least 3 variants, 2, 3, or 4 of the ApoE gene. And if you have 1 or 2 copies of E4, you are at increased risk. And as I mentioned in my presentation, both exercise, diet, and I should mention as well, use of your brain can offset that genetic risk. So we shouldn't have a fatalistic view about the common genetic predispositions, which affect most of us over the age of 65. They don't really click in until 65 or above. So we can change our lifestyle to oppose those genetic effects.
Next question is, maybe, here we go. Okay, next question is explain how hearing loss may be correlated to Alzheimer's.
Well, there isn't any direct correlation between hearing loss and Alzheimer's. That's not known in the literature. It doesn't generally come up in clinical trials. But smell is certainly correlated with Alzheimer's disease. In fact, because our sense of smell directly feeds into that part of the cortex where the hippocampus exists, it bypasses our cortex completely. This is why, when you walk across a field and it's cut grass, you're thrown back to when you're 6 years old or 5 years old. Krauss famously wrote about this connection that our brain, this trick that our brain does for us. So the loss of olfaction, the loss of smell is an early clinical sign of Alzheimer's disease because it indicates damage to that part of the brain where the hippocampus resides.
Next question is there any research on adult learning disorders and the crossover to Alzheimer's disease?
No, there isn't in general, but there isn't specifically, but in general we know that insults to the brain have this predisposition to push Alzheimer's forward. So there are many types of insults, and Mike touched on some of those. But no, there's no direct links. Interestingly too, that folks with learning disabilities often compensate by having exceptional abilities in other parts of their brain. So consistent with what I told you about the taxi drivers, for instance, if you look at those parts of the brain in such individuals, you actually see that those parts of the brain have expanded to compensate. And so, but no, there's nothing in the literature suggesting a direct link.
And this question is for Dr. Murray. Someone says, so how much wine can I really drink? I knew we were going to get, I told you wine was going to come up, so.
A good friend of mine has done more brain scans than anyone on the planet. I think he's now done over 90,000 brain scans, and you can always tell the person has a glass of wine every night. So I don't have a glass of wine every night, so I'm not a good person to reinforce that idea that we can gain benefit.
Although conflicting studies on that. Just have to say, as a health reporter, seen a lot come through that small amounts of alcohol, not a lot in one sitting. That's what in my reporting. If you're drinking 5 drinks in one night and none the rest of the week, all those studies come back negative. If you're drinking 1 glass, would you say that's most of what the research shows?
Yeah, there's actually teetotalers are at higher risk for dementia than non-drinkers. It's a J-shaped curve, which means that if you drink a little bit, your risk goes down. If you drink too much, of course, it goes way back up again. For other reasons, not actually for Alzheimer's disease, but you can get alcoholic dementia. But a little bit of alcohol looks like it's protective.
So then we define what is a little bit of alcohol, and it's, those studies are usually once or twice a week, not every night.
Right, that's up for debate, yeah.
Up for debate. What about coffee?
Coffee is an interesting subject. Just this week, a positive study on overall mortality, but I put a caution there. If we look at the research on coffee and caffeine consumption and heart disease risk, there are studies showing that coffee increases the risk of having a heart attack or stroke, studies that show that it prevents heart attacks and strokes. So back in 2006, some researchers asked the somewhat obvious question. Maybe it has to do with the way people break down caffeine. And so they looked at people that were either fast metabolizers of caffeine or slow metabolizers of caffeine. And so what they found was that people that were fast metabolizers of caffeine, if they drank 2 to 4 cups of coffee a day, they would reduce their risk of having a heart attack or stroke by about 46%. On the flip side, if a person was a slow metabolizer of caffeine and they drank 2 to 4 cups of coffee a day, they would actually increase their risk of having a heart attack or stroke by 250%. So the question is, how do you know if you're a fast metabolizer or a slow metabolizer of caffeine? The answer is people know. They may not want to admit it, but if caffeine makes you a little bit anxious, irritable, and have a hard time sleeping, you're likely a slow metabolizer of caffeine. You need to stay away from it. About 50% of Caucasians are slow metabolizers of caffeine. Only about 10% of the Asian population are slow metabolizers. So if you look at a study that was done in China on caffeine or coffee intake or tea intake, green tea, black tea, it doesn't matter, it's going to show tremendous health benefits. But if you look at other populations, you're going to see different results, because what really comes down to is our own individual biochemistry, and not all things are good for all people. And so that's where the case study of Lund comes into great value. So to answer your question, for most people, coffee is really good.
I just wanted to make a general comment about newspapers and media in science and what we see, what we're exposed to in that regard. And we have a maxim, which is that association is not causation. Just because something's associated with a disease doesn't mean to say it causes it. My analogy for years and years was always, you go to the site of an aeroplane crash, if that's what you do for a living, you see seat cushions everywhere, and after a while, when you've been to the 10th aeroplane crash, you say, you know what, these seat cushions are everywhere. That must be what's causing the aeroplane crashes, right? Because they're at every single one of the sites. And that's true of Alzheimer's disease. So we could make up science studies right now which we know would be positive. So if we looked at people that were in nursing homes versus those that weren't, guess what? The ones in nursing homes have more Alzheimer's disease. That doesn't mean to say that the nursing home is causing, and it's true of so many things. So just massive amount of caution, and always think that way when you see some new article that's come out that this increases the risk. Well, it may just be a biomarker for the risk. A good example is something like vitamin vitamin D. We can't see an easy biological link between Alzheimer's disease and vitamin D. It may be that it means we don't get out in the sun much, and which means we're not exercising much. And that may be the real underlying cause. So just be very careful about those associations.
Exactly. When you go to read the actual study, or you read deeper into the article, because I know a lot of us read just at the beginning, it will say, researchers stress that this study does not prove that XYZ causes this disease. There was just some association. No, there could be many other factors. So thanks for pointing that out. We have a chance for one more question, and then I will finish it out with a final question about something in the presentation. Well, one final audience question was, what are your thoughts on cannabinoids and the relationship with Alzheimer's? Are you currently conducting research? This is from Dr. Jim.
Is actually we're looking at endocannabinoids, which are some of these cannabinoids can have anti-inflammatory effect, and they can certainly impact our lipid balance and the types of lipids that we have in the brain without eliciting the psychoactive effects. So we've actually been working on that for a long time at the Institute, and there may be some potential as a way of reducing the risk.
Before I ask this final question, I have to announce that we just received an anonymous $10,000 donation. So thank you to everyone, but especially for that large donation. And the final question is, I think for Dr. Crawford, when will trials for nalbadapine begin in the U.S.? What about approval? What do we know?
So we're actually in the process right now, and actually this is really more a question for Dr. Mullen, but we are in the process right now of working out the next steps with nalbadapine. It's a difficult path. Anatomy. Oh, sorry, please. Nalbadapine.
Nalbadapine.
Yeah, I thought
yes.
It was nalbadapine. One of the issues is that nalbadapine has never been available in the United States for hypertension or anything. We think this may be because it's a very weak antihypertensive, as Dr. Mullen said, and so to introduce it here in the United States, it gets considered as a completely new chemical entity by the FDA. Now the good news is that there is supposed to be, for many years now, there's supposed to be a harmonization between Europe and the US in terms of moving drugs forward. And certainly, if things moved forward in Europe with nalbadapine and showed hope and expect that the amount of pressure that would then be brought to bear to bring it into the United States will be quite considerable. But I'm going to hand over to Mike to sort of wrap up.
Well, I mean, typically the route would be to get approval for Alzheimer's disease and then go sideways into other conditions such as TBI.
Well, a huge thank you to all of our wonderful panelists today. And you may have already seen this on social media, but we just want to announce that next year's event has already been rolling, ready to go. The date is September 28th, 2018. We hope to see you all back next year, and please spread the word in the meantime. And remember that this sold out super quickly. We expect the same thing to happen. We hope to even boost the size of the event for next year. If you want to learn more, roskildeninstitute.org/events for more information on that, and throughout the year, many other ways to get involved. So thank you all so much. Learned a ton, and we hope to see you next year.
You guys could ask a lot of stuff.